All right, so now we're going to look and go back and revisit variable expressions and evaluating expressions with our new properties in place. So until now, if we were talking about a variable expression, we would have meant something like 2x plus 3. But they can be much more complicated than this. A variable expression could have 5x plus 2x plus 3. It's still a variable expression because it's just an expression, no equal sign, and it has variables in it, called a variable expression. These have a greater complexity, and we need new terminology to describe them. So let's start with the parts. Notice that this is an expression that has 3 parts, and the parts are separated by signs. These 3 parts, we call each one independently a term. So this has 3 terms in it, a 5x term, a 2x term, and a 3 term. Notice, though, that some of these terms are similar and some of them are not. For example, this last term doesn't have a variable attached to it. When you have a term that is only a number and not a variable, we call it a constant. We might even call it a constant term. These first 2 parts, or first 2 terms, have both a numeral, or a value, and a variable. In that case, we actually have a name for the numeral part, the 5 and the 2 in this case, or the value part. We call those coefficients. Coefficients. And, by the way, x's are still just called variables. So the only new terminology here is that when we have an expression, a variable expression, each part of the variable expression is called a term. The part of the variable expression, or any part that doesn't have a variable with it, is called a constant term, and the value of terms that contain a variable are called the coefficients. And then one other definition that we need. Suppose I have a variable expression 5x plus 2y plus 3x plus 6. So now I have a variable expression because I have values and I have variables and there's not an equal sign. So if I want to evaluate that, well, first I have to be able to identify the parts. So in this case, the constant term is 6. Nothing has changed here. But I have 3 terms that look different from each other. So I would say that each of these is a term, but even when I'm looking at my variable terms, they have a different look about them. Well, 5, 2, and 3 continue to be coefficients, but 5x and 3x, because they have the same variable attached to them, are called like terms. So 2y is not like 3x or 5x because the variable is different. Like terms are terms that have the same variable configuration in them. And just to be abundantly clear, it doesn't really matter which variable is attached to it. The number part, the value, the numeral, is still a coefficient. So in the second expression, 5 is a coefficient, 2 is a coefficient, and 3 is a coefficient. Okay, so let's look at a variable expression and identify all the parts. 13c minus 4 minus 5c minus 6. We want to identify the terms, the coefficients, the like terms, and the constant term. Okay, so let's start with the terms. Well, remember, each part is a term. And it's super important to notice that the sign goes with the term. So one of the terms is 13c, that's this first one. Another term is -4. Another term is -5c. And another term is -6. So the sign goes with the term. Coefficients. Well, coefficient is the value associated with each variable. So 13c, 13 is a coefficient. 4 does not have a coefficient. -5c, -5 is a coefficient. So like terms, those are the things that are alike. They have the same variable configuration. Well, 13 and -5, or 13c and -5c, have the same variable configuration. And -4 and -6 have the same variable configuration. So like terms, 13 and -5c are both like terms. -4 and -6 are like terms. And then the constant term, in this case we have more than one. -4 and -6 are constant terms. Now let's do an example where we evaluate an expression or simplify an expression using all of our new properties and all of the information we had before we came in. We have 12k minus 9 plus 4b, excuse me, looking at two problems here, 4k minus 9 minus 7k plus 20. So if I look at this, I can actually easily see that I could mix 20 and -9 together because those just simply add. Well, it turns out my like terms can always be combined. So in this case, I have like terms, and I have another set of like terms. And part of simplifying is combining those like terms. So I could combine like terms. That's not a big deal. But notice I can't combine this 12k and this minus 7k because there's a 9 here in the middle, a -9. That's okay. I know I have commutative property that says I can switch the -7 and the -9, or excuse me, the -7k and the -9. I can just switch these back and forth. Except, remember, the commutative property of addition is addition, but I have subtraction in here. No big deal. I can convert this whole thing to addition. I have a plus 12k plus -9, because remember, adding or subtracting a number is really just the same as adding its opposite, plus -7k plus 20. So all I've done now is make it a sum. 12k plus a negative integer plus another negative term plus 20. Now I can do my switch. I can apply the commutative property and just switch of addition and just switch those two numbers out. So I have 12k minus, or plus, excuse me, minus 7k plus my -9 plus 20. Now I can combine all of my like terms perfectly well. I can take my 12k and -7k. So I have 12 red marbles and I subtract 7 red marbles. I'm left with 5 red marbles. So k's work, or variables work, like having a possession of something in your hand. You just count them up and you add and subtract on the number line, just like we've been doing all along. And then -9 plus 20 on the number line, that would be start at -9, and I'd have to go all the way over to 20, which means 9 of them take me to 0. So 20 take away 9 is plus 11. So I'm not doing anything differently, but my numbers have gotten much more complicated. It's okay, as long as I use all my properties and my rules effectively, I'm good to go. Okay, so let's do another one. This time we want to simplify the expression 5 times, using parentheses for times, 6 plus b plus 4b minus 9. Okay, so sometimes it's hard to know where to go from here because you have a lot going on. We're still using order of operations, PEMDAS. Okay, so let's do a checklist. Start with our parentheses. We certainly have parentheses, but we can't combine these. This is a variable term and this is a constant term. They're not like, so they can't be combined. So there's nothing I can do for parentheses at this stage. I also have no exponents. Now I want to look and see, do I have any multiplication or division? And I do, because this is a single term number multiplied to a two-term number. No big deal. That's called distribution property. We totally know what to do with that. We're going to take 5 times 6 and then 5 times b. So 5 times 6 is 30. 5 times b, well, I have to worry about the signs. Positive and a positive is a positive, and 5b's is 5b. Now bring down the rest because I finished this part. I'm going to cross it out. I have finished that. Just bring everything else straight down. Plus 4b minus 9. What can I do now? Well, my like terms are certainly together, so I can use combine like terms. I have 5b's plus 4b's. 5 green marbles plus 4 green marbles is 9 green marbles. I'm finished with this part. Bring everything else down. Okay, now I've got some trouble because I know I can combine 30 and 9 because they're both like terms, but I have this 9b in the middle. No big deal. I'm going to use the commutative property of addition. Oh, look, this is subtraction. I'm going to have to make a conversion to addition. So let's rewrite this. 30 plus 9b plus negative 9, because subtracting 9 is the same thing as adding a negative 9. Now I can switch these two using the commutative property, and I get 30 plus negative 9 plus 9b. And 30 plus negative 9 is just 21 plus 9b. Let's do a couple more of these. I think these are a very kind of difficult process, so I want to do enough examples so it starts to show the pattern. Let's combine 4m plus 12 minus 3 times 2m plus 2. Okay, we've got a lot going on again, but just like before where we used PEMDAS, we can't combine what's in the parentheses. There are no exponents. Multiplication, division. Here's my multiplication. So I'm going to multiply 3 times 2m plus 2. So, well, remember, the sign always goes with the term. So this is negative 3 times 2m. That's a negative and a positive makes a negative. 3 times 2 is 6 times m, 6m. A negative and a positive. Let me put my loops in here just so I'm sure we all know what I'm doing. A negative and a positive is a negative. 3 times 2 is 6. So I've now finished with this part. I'm just going to bring everything else straight down. Okay, again, I'm going to want to switch my middle two because using the commutative property of addition, because if I do that, then my m will be over here next to my other m, and my 12 will be over here next to my 6, so I'll have like terms together. But I have to convert this to addition first. 4m plus 12 plus negative 6m plus negative 6. Now I can use the commutative property of addition, switch those out. 4m plus negative 6m plus 12 plus negative 6. First, let's combine the like terms that contain the variable m. And so we know 4 plus minus 6, if I were using the number line, right? I would go from 0, I'd go to 4, plus, headed the right direction, plus minus, I'd go to 6, which means I'm going to be at a negative place. I moved 6 units, but 4 of those were just getting me to 0. So negative 2m plus 2 plus 12 plus negative 6, same thing, 12 take away 6 is 6. And that one's finished. Okay, and I think one last example would do us good. 15x minus 10 plus 15x. So this one's a little bit tricky because you want there to be something to multiply with this part inside the parentheses. Because when we look at our PEMDAS, right, we can't combine what's in the parentheses and there are no exponents, so we're looking for a multiplication. I clearly have one, but I don't really know what to do because there's not a number there. Well, it turns out there is a number there. It's just a number that we don't write unless we need it. There's a 1. So a minus 1, and I'm going to write it dotted in because it's the number we never write unless we need it. And right now I need it because I want to do the multiplication. So if I decide to do that multiplication this way, I have negative 1 times 10. A negative and a positive is a negative. 1 times 10 is 10. Negative 1 times 15x. A negative and a positive is a negative. And 1 times 15 is 15 times x is x. Remember? Because we're looking at negative 1 times 15x is the same thing as negative 1 times 15 times x. So I do this part first to get negative 15 times x, and negative 15 times x is negative 15x, and that's where I am right there. So I finished this part, and all I have to bring down is my 15x. I want to use the commutative property of addition, but I don't have addition, so let's switch it. 15x plus negative 10 plus negative 15x. Now I can switch these two. Negative 10 plus 15x plus negative 15x. Negative 10, 15x plus the opposite of 15x is just 0. So the answer then is negative 10.